You know, for centuries, science has been chasing one big, beautiful dream, a final theory of everything. But what if that entire quest, that whole dream, is built on a fundamental mistake? Today, we're going to dig into biologist Stuart Kaufman's absolutely radical argument that this dream isn't just far away, it's impossible. Yeah, he doesn't pull any punches. This isn't some minor academic squabble. This is a challenge to the very idea that our universe can be completely understood with a single set of laws. So, how on earth does he build a case like that? I mean, think about it. This idea of a predictable, knowable universe has been the bedrock of Western science for like 2,500 years. Plato called it the logos. Newton pictured this perfect giant clockwork machine. The core assumption was always the same. Everything that could possibly happen already exists as a possibility. Physics is just the rule book. But Kaufman says, nope, that's the mistake right there. All right, so where does this grand old idea start to fall apart? Well, the first big crack shows up when we run smack into the messy, creative, unpredictable world of biology. Okay, so think about it like this. Physics, from Newton all the way to quantum mechanics, pretty much works with what's called a pre-stated space. It's a fancy term, but it just means all the possible outcomes, all the ways things can be arranged, are already laid out from the very beginning. But biology, man, biology seems to be playing a totally different game. It's not just picking from a preset menu of options, it's constantly writing new items onto the menu, things that weren't even conceivable before. Let's make this real. Think about your own heart, right now. It's a physical thing, right? Made of molecules, all obeying the laws of physics. But how did something that incredibly complex and functional ever come to be? If all the possibilities were already out there, you might think the universe just sort of found the heart configuration by random chance. Well, the math tells a very, very different story. The reason comes down to this really crucial idea. The universe is not ergodic. Now, that sounds technical, but all it really means is that the universe hasn't had anywhere near enough time to try out all the possible combinations of its parts. It can't just randomly shake the cosmic box and have a heart fall out. And if you want to get a sense of just how impossible this is, check this out. A pretty typical protein is about 200 amino acids long. The number of possible ways you could arrange them is 10 to the 260th power. That is a 1 with 260 zeros after it. I mean, that number is so mind-bogglingly huge, it's bigger than all the particles in the known universe. By a lot. So here's the bottom line. There is simply no way the universe could have made a heart by just trying out every possible protein combination. It is not physically possible. So, random chance? Nope, that's off the table. Which leaves us with a huge question. If not by chance, then how? Well, this leads us to biology's brilliant and incredibly creative workaround. You see, life doesn't search through some vast pre-existing library of possibilities. Instead, it builds on what it already has in ways that are truly new and unpredictable. To really get this, we have to talk about something called a Kantian hole. It's just a way of describing any living thing. You, me, a plant. Think about it. Your heart exists for the sake of your body. But your body, as a whole, exists because it has a heart. The parts and the whole need each other. And because of that special relationship, we can finally talk about the function of a part. And this part is key. A heart's function, we say, is to pump blood. And it is. But that's just one of the many things it does physically. It also makes those lub-dub sounds, right? It jiggles the fluid in the sac around it. It has tons of these little physical side effects. And here's the amazing part. Any one of them could, under the right circumstances, get co-opted for something completely new. This process actually has a name. It's called Darwinian exaptation. It's when a feature that evolved for one reason gets grabbed and used for a totally different, completely unforeseen purpose. I mean, a perfect example is your tongue. It evolved to help with eating, and hey, now you're using it for speaking. That is the creative engine of biology. Let's walk through a classic example. You've got some ancient fish with simple little lungs. But then, somewhere along the way, a new use is found for this little air sac. It helps with buoyancy, with floating. So over generations, this feature gets refined into a specialized swim bladder. And here's the kicker. The moment that swim bladder exists, it creates a brand new possibility in the universe that was never there before, a niche for a type of worm that can evolve to live only inside swim bladders. And this is not some logical, predictable process. You could never, ever have looked at a primitive lung and deduced that it would one day become a swim bladder that hosts a specific worm. You can't predict it. Each step is a genuinely new invention, not some pre-written destiny. So this endlessly creative, non-deducible process, it means we're dealing with a part of reality that lies completely outside the neat framework of physics. Kaufman gives this domain a name. He calls it the indefinite.
So what is the indefinite? Well, it's defined by a few key things. First, you can't make a complete list of all the possible uses for something. Second, you can't put those uses in any kind of logical order. And third, you can't deduce one from another. It's just like you can't list all the possible uses of a screwdriver. You can't list all the possible evolutionary paths for a heart. It's indefinite.
This paints a completely different picture of the universe, right? Instead of a place with a fixed set of possibilities, we've got a universe where the set of what can happen is constantly growing. The very possibility for a tiger to hunt a gazelle simply didn't exist 3 billion years ago. It had to be created. This ever-expanding frontier is called the adjacent possible. Evolution isn't just searching a vast, static landscape. It is constantly creating the very next set of possibilities right in front of itself and then stepping into them. And this isn't just biology. Think about technology. You couldn't invent a cannon until you first had a church bell, whose shape could be repurposed. The bell created the adjacent possibility of the cannon. So if Kaufman is right, this doesn't just change physics. This changes our entire relationship with the universe and our place inside it. This idea really points to a profound cultural shift. You have the old scientific worldview, the one from Plato to Newton, that saw the world as a predictable machine. The goal was to learn the rules and achieve control, achieve dominion. But if the universe is endlessly creative and unpredictable, our goal can't be control. It has to shift to something more like wise participation. Just think about what that really means. If we can't even list all the things that might happen, how could we ever hope to master them? The dream of total control isn't just arrogant, it's logically impossible. And what's so fascinating is how this cutting-edge scientific idea also happens to echo some very ancient wisdom. Kaufman himself makes this beautiful parallel to the Tao Te Ching. The biosphere that can be described is not the biosphere that will become. It's always in a state of becoming. And so we're left with this. If reality isn't a finished puzzle just waiting for us to find the last piece, but instead it's an unending story that's writing itself as it goes, then what's our role in it? It suggests a future not of mastery, but of collaboration, with a universe that is just as creative as we are.